We are going to discuss about parallel axis theorem. What's the parallel axis theorem? What's the purpose of using it? How it is used? We are going to discuss today. We will be discussing a work example for you to understand this very easily. Let's start. Parallel axis theorem is used to transfer the second moment of area to a different axis. When you need to find the second moment of area in a different location, then we can use this parallel axis theorem. Generally, moment of inertia of different axes will be considered parallel to the previous axis. As you can see here, I have shown a body that having the center of gravity somewhere at the middle. So the axis xx is going to the centroid of the body. Then we are going to find the moment of inertia of AA axis that is parallel to XX axis located d distance away from XX axis. So according to the parallel axis theorem, the moment of inertia about AA axis can be written from this equation. I at AA axis can be written as IC, that is moment of inertia at the centroid, and the m plus m into d square. Here m is the mass of the body, d is gap between two parallel axes. Now let's work out the example for better understanding of this. This is a theory and this can be derived from the equations. From the first principles you can derive this equation, but you can directly use this equation. Always you don't want to derive this equation directly, you can use this equation. When it comes to a area section, we can write this equation. I is equal IC plus AD square. Instead of mass, we can use the area also when you consider a cross section. In addition, here as we discussed, we used to find the second moment of area or the moment of inertia in a different axis. This theory can be used to find the moment of inertia at the centroid. If you know the moment of inertia at different axis, then those cases we can use this theory to find the moment of inertia at centroid. Now let's work with the example. Let's consider a rectangle having dimensions b and h. Let's consider its centroidal axis as xs. Right. Let's see, we are going to find the moment of inertia at this h. That is, let's say it's AA. We are going to find the moment of inertia at AA. First, we need to calculate the moment of inertia at centroid, that is IC. Say equal, from this, for rectangle we all know 12 into BH cube. So this is from the theory. For rectangle about the centroid, the moment of inertia will be 1 over 12 into h cube. The area will be of this rectangle b into h. Now d distance will be, so total height is h, then that is h by 2. Then we can use these values to substitute this equation number 1. Right. From the equation number 1, inertia about AA axis equal IC we have already calculated 1 over 12 BH cube plus, now AO we know now, BH into h by 2 d square, that is h by 2 square. This can be calculated as 1/3 BH cube. Of this rectangle about AA axis, the moment of inertia will be BH to the power 3 divided by 3. So similarly, you can use for any cases you can use this theory to calculate the moment of inertia or of any situation. For example, say this something like this. So this is centroidal axis. So if you want to find this one, if you know the values here, so you can use this theory to calculate the moment of inertia above central axis as we discussed previously. I hope that it is now clear the method of calculating the moment of inertia of a different axes. So if you know the moment of inertia centroid, and if you know the cross-section area and the gap between these two axes, then we can calculate the moment of inertia. I hope that this was useful for your knowledge. Let's meet again for my video. Thank you very much.